prices. So for us, if we really want to ensure a sustainable future, we need to take care of our soils. And it's great to see how here in India, which is a country that is leader in agriculture, you are very aware of this, and you are taking actions for protecting your soils. So what is health soil? If we agree that only living things can have health, then we should look at the life in the soil. And it's really amazing the quantity and diversity of life that we find and the role that they play in key processes in the soil. We at Biomakers, we use the soil microbiome that includes bacterial and fungi communities as a bioindicator of soil health. And we connect this to the digital world using technology and artificial intelligence. So with our big crop technology, we transform soil microbiome DNA data into functional and ecological predictions. We also compute in situ and remote environmental data. We integrate agronomic insights, and we also learn from trials with bioproducts. So the result is a unique soil intelligence platform for soil management and recommendations. And I say this is unique because we've been processing samples and training our models for 10 years. We have validated the technology through different scientific publications and also through different patent applications. Some of them are already granted. This is an example of our most advanced solution in which we can map and predict for the first time microbial metabolic pathways at the farm level with high resolution. And this serves, for example, to identify deficiencies or disease risk. We can also recommend bioproducts where they are really needed and also assess the sustainability of the farm. Today, we are selling our big crop technology through three different solutions that address the needs of the stakeholders across the whole value chain. So we have a price per test model, for example, for the big crop test and the big crop for trials. And also we have a price per acre model in the case of a big crop farm. This is our team. The company was born in the United States, in California, but now we are a global team. We are 50 professionals from different disciplines and cultural backgrounds, and we have also the support of a very experienced advisory board. Today, we have a global reach. Our scaling strategy is based mainly in building a global network of partner laboratories that operates under our standard procedures, and also building strong partnerships with key actors in the whole ecosystem, from farmers to ag input manufacturers or large food producers. And I'm happy to share that now we have also presence in India, thanks to a new agreement that we started with Agrocel, a laboratory called Agrocel. So if we win the prize, we will definitely use it to promote this collaboration and to contribute to protect the health of the soils here in India. We really believe we are having a very positive and real impact, and that's why every year we release a dedicated report. For example, we have been able to reduce by 20% the use of agrochemical fertilizers. And just to finish, we are always like to say that better soil is better food and better life. So thank you all for your attention.
Thank you for your presentation. We now open the floor for committee members to pose their queries.
Thank you for the presentation. You talked about numerous stakeholders in the partnership and collaboration. Can you talk a little bit about the feedback loops and any evolutions that you've like returned to the system, and specifically feedback from farmers themselves?
You mean if we receive feedback from the
Yes.
farmers?
Yeah,
Yes,
how that's built in, and have you seen or developed product evolutions based on that feedback?
that is really important for the product development, because sometimes the farmer receive many data and very complex, and they say, okay, but what do I do with this? So we are working hard to translate this complex information into actionable insights, so they can take actual decisions for improving the soil.
And has there been any, lessons learned or evolutions or changes based on some of these inputs and feedback from?
Oh, well, sorry, can you repeat?
Just obviously with farmers at the core, have there been any inputs or feedback directly from farmers that have led to different changes in the product development and cycle and the work?
You mean, oh, sorry, I don't understand. I believe she's wanting to understand the feedback of your users, the solution users.
The user feedback.
What is the feedback from the user group? Be it farmers or someone else, what is the feedback that you've received?
Yeah, it says some of the feedback, it relates to our digital platform, because they can get their results, they can track the status of their samples through our portal, and also get the results and the reports, and they can also use different tools. So sometimes the feedback is in that direction, I don't understand how to interpret this result, or I found it difficult to combine these two indexes, I don't know the meaning, so that's the kind of feedback we normally receive.
I think the question is, because of the feedback, what changes to the product you have done to date, if any?
What is?
How has your product changed because of any of the feedback that you have got?
How is the product changed?
Yeah.
We are constantly improving the user experience in the digital portal, mainly. And also, sometimes we are also improving our microbial indexes, so they can fit better what is expected by the farmer.
In case there are no further queries, we can wrap up this presentation.
Thank you.
Thank you for your presentation. Now we have a team from India presenting Resilience 360, which is a climate risk management and resilience tool. We now welcome them on the stage.
Thank you. Namaskaram, India. And a very good afternoon to all of you, ladies and gentlemen. My name is Samhita. I represent Resilience AI. We are going to talk about natural disasters, where we believe is a true application of AI to solve a problem that touches each of us in this room. A $400 billion losses, 394 plus disasters, and please remember, 3.5 million lives lost. This is not just rural and urban locations of US, India, Philippines, Japan, but this is also our businesses, our supply chain, and more importantly, trade and livelihood. It impacts every industry, and that is where we come as practitioners of natural disasters, technology, urban planning, architecture, finance, and economics. This team is rooting for each of us today on natural disasters coming with AI from North America, Canada, and India. What have we built? We have built a single window system which can be accessible by any of you in this room in any capacity using a login and password. What does it do when you log in and you generate it using your password? You have 4 things at your discretion. Intelligence number 1, data sets are abandoned, but will you be able to understand flood velocity? Would you be able to understand a hydro if you are the CEO or a CFO of a company? If you are an administrative officer responsible for your jurisdiction and administration, would you have the time to understand what is an urban heat island effect? The answer is a simple no when we started it with our research. What we are doing is at a location-based level, at every hyper-local structure, including the building we are in today, give you an answer of what is the magnitude of damage to 6 types of natural disasters in 30 minutes at 96% confidence. Great, now we understand if the structures we live in, work in, our children are going to schools in, our warehouses, our stocks, our revenue, everything is locked in, it's safe. What's next? Next is compliance. It's a very critical component of the entire conversation, and we are solving it using generative AI by giving you a resilience factor where we are mainstreaming how you should define resilience, because there is so many conversations and definitions about resilience in climate. Moving forward, what we are also doing is ground truthing it, and this gives evidence to the fact that we are science-based, we are aligned to the 3 chakras of this mission that we stand for today, we are part of the PM 10-point agenda, and we have been recognized very humbly by Ministry of Home Affairs, National Disaster Management Authority, which is the nodal agency to decide whether the software has the science, has the intelligence, and is credible. We are also very ground-truthed in our intelligence in terms of the village and urban. Natural disasters does not discriminate whether you are living in a rural India, rural America, or you are living in an urban city. We have deployed this with United Nations in 84 villages of India. We are deploying it in 8 cities. We have been working with data centers and hospitality sectors with Mahindra, and the customer trail has been going in. In less than 9 months, we have generated enough revenue to be able to start expanding. We are targeting a market of about 50 billion, which is our operational market in 3 countries. If I tell you the slide in the first one, and you had the devil in the details there, 3 countries contribute to 50% of the disasters in the world: North America, Philippines, and India. And we are going to serve these countries by making them resilient. Our go-to-market is very simple. We believe that this is an ecosystem play. We do serve the government and the business enterprises directly, but we have a very strong channel partner base who are taking this deployment as part of their service tool. We have been growing very poisedly. In the last 2 years, we have locked in about 200K revenue, and we are moving to more than 10x growth, breaking even next year. Why Resilience 360? That's my last 59 minutes. The journey has been phenomenal. We are novel. There is a copyright and patent file. The copyright is secured. We are valuable. Everybody wants and needs to solve natural disasters for business resilience and your city resilience. We are scalable. You can use the same tool for India, for anywhere in the world, and we have been deploying it in multiple countries. We are doable. All you need is an ecosystem. We are not an analytics player. We are much more advanced than it in the way we are using the science and making meaning out of it, and we are using the algorithm at the back end. Thank you so much for listening in to us, and we are open for questions. I'd want to invite Sandeep Reddy Malu, my co-founder in this journey, to also join me for the Q&A. Thank you.
Thank you for your presentation, team, and thank you for sticking to the time limit. We now open the floor to the jury members to pose their queries now.
I have a question. What are the outcomes? Is it more preventive or is it more recovery in terms of the Resilience 360 outcomes?
Is there a language model around it? Do you want to take the language model around it?
There are 2 parts of how we have looked at the language model, sir. One is a visual language model that helps us to understand the current land picture pictography of evolving landscape over a period of time. So we have a custom-built visual language model that helps us understand the change in terrain, change in vegetation, change in physical structures that are being built, degraded, damaged. That's step 1. We take that as a baseline and combine it with change in climate indices that happen in a given area or a period of time. So we are able to say that in a given year, when there was rainfall of, say, 200 mm in an annual basis, what has happened from an inundation standpoint, when the landscape shifts, vegetation is removed, new roads came in, how does it impact permeability of the soil to absorb water? We have an ability of a secondary model that makes these step 1 inferences and combines that with climatic change models to make the conclusions of what has been a shift in risk. So that's how we have 2 broad categories of paths that we have. So
I'll just add a content to that. The science that we have trained the machine on are 3 sciences. Science number 1 is climatic. When you have heat, you have to understand temperature, but you also have to understand what is the wet bulb temperature indoor. Both of them come together. You have to understand precipitation. You can't take that in silos. So we have taken that cluster of information. The second science is geological. Geological means what is the proximity to a water body? What is my wetness index? Is my soil moist enough? That has a huge relevance in how the urban heat island effect suddenly starts framing as clusters. The third data information that is proprietary to us is the 8.9 million structures which we are very proud of, where we have been studying built environment, whether you're an RCC structure, whether you're a virile structure or a tarpaulin, or you're an engineered wood structure, because these are there across the world. We have been annotating them and feeding them back to the machine learning to understand it in correlation to geological science and in correlation to climatic science. Why do we do it? I'll give a very simple example from our lived experience. We come from rural India. A mud hut is better in extreme heat than an RCC structure, a concrete structure. A mud hut is more vulnerable to flood than an RCC structure. Even better, if you are a bamboo structure which is standing, which is the northeastern belt, the hilly regions have that, it's even more sturdy. So having this combination made more meaning to us when we were solving for hilly terrains. And as I say, there are 17 plus geoclimatic terrains. It was more meaningful to us to have this combination before we, or have this combination in training the learning model.
And a related question is, has there been an example of that you can show where urban planning has got bettered because of using your...
Okay. Since we are too early in the ecosystem, the answer is the response we have given for Dharali in India, which has happened, and we have made a submission to it, that had Resilience 360 been deployed there, we would have told you that debris is going to flow in this region. But more importantly, we would have told you that the tourist center was highly impacted and the building that was just beside it would be left untouched. That is the intelligence that we have been able to do it. We have just finished it for Chantal, which is a storm in US, and we are building our presence in North Carolina. Both the government and the community has been overwhelmingly accepting us as part of the ecosystem. Thank you so much.
We have time.
Thank you for your presentation, team. The next presentation is by Elementech Circle Private Limited, which is providing an AI-powered smart meter intelligence and demand response platform. We now request the team to come on the stage.
Do you have a... Thank you. 300 million. 300 million was the total population in India in the year 2012 without any access to electricity. And that number stayed with me because it was roughly around the same year that I decided to move to the United States to pursue my master's degree. And a quick search on the total population of the United States at that point showed up that same 300 million number. And really, that is the scale of the problem that was in place in a country like India. And the vivid picture that I had in my mind while I moved to the United States to really look at addressing this problem. Over the course of the last decade or so, we've provided access to electricity to that entire 300 million, and today provide affordable access to power to 1,400 million and counting. Now, I know that's no mean feat because I want to remind everyone that we've come so far, but there's such a long way to go because the origins of our entire work and efforts were built around the two extremes that we see in India. The electrification story, and then what we've seen with solar, for example, we've 100x'd in terms of deployment over the last 10 years. Today, solar is the cheapest form of electricity generation anywhere in the world. But at the same time, if you look at the GHG emissions, India is already the third largest emitter of greenhouse gas emissions. But at the same time, if you look at the per capita emissions number, we're 103rd in the country ranking list. And therein lies the dichotomy of the largest population on the planet, but at the same time, a country that's still very much in its growth, development, and advancement stages. So as the expanding economy and with the influx of AI and all the compute, the task that we have ahead is to decouple growth advancements from emissions, something that's been particularly challenging for entire countries around the world. Now, where do you start? That's the question that we asked ourselves. Two things in this particular slide that I want to highlight. The cost of electricity is the highest today in India for the commercial and industrial sector. On average, they pay 40% higher. And what we said was we'll go after this particular segment because India is also building close to 700 to 900 million square meters of urban area. And really the stat that really led me back to moving back was India is building the equivalent of a Chicago-like city every single year for the next decade and a half. That's the sheer amount of construction, development, and growth this country is sort of seeing. Now, all of our work started at IIT Madras, and the work we've developed, tested, validated, is now a showcase at the IIT Madras Research Park campus, and my entire solution that we've developed is going to be a case study that I'll walk you through over the next 2 slides. For context, we're a 1.2 million square feet commercial complex housing about 5,000 people, 250 corporates, 100 startups. Our average energy consumption is about 70 megawatt hour per day. We've sort of looked at how do we address this from an end-to-end manner. Essentially a 4-pronged solutions approach: efficiency, generation, storage, and then management. This is a quick analysis of efficiency. We have done a geospatial modeling to understand the heat gain within the facility. And if you can see that picture on the bottom, it shows that one particular building, which is the west-facing facade, is exposed to 30% more heat gain. That means I'm spending, for the same room, same size, just because it's oriented in a different direction, 30% more energy in just cooling that space. We're using AI to optimize, learn, and solve for problems like this. On the energy generation piece, solar and wind, as you all know, is already scaling. What we've done is also build out storage. This is a thermal storage system, a 300,000 liter tank at the basement of our facility. Whenever there's excess solar or wind, chill water, store it in the tank at 6 degrees Celsius. Whenever there's a deficit, use that chilled water for cooling and all of the cooling requirements. Now, the layer on top of this is managing. Real time, you need to optimize and essentially manage all of the energy generation, storage, and the usage that's happening. And what we've seen is the AI layer on top is solving for all of this. And our entire journey was documented through the Zero to Green open source library, where we found that there was a 35% reduction in costs, bringing down our electricity bills by 42 million in a single year. This approach is what we're saying is scalable across the country. And just quick 30 seconds before I close, this is a statement that was put out by Anthropic, which shows that they're going to cover all infrastructure upgrades in the grid. And that's exactly the direction with which we've gone. Essentially, we've tied up with the Ministry of Power and essentially deploying demand response programs for AI optimization of the entire state of Andhra Pradesh. We've signed up with industrial and commercial customers to essentially manage the demand and supply of electricity. The problem, which can be highlighted in the graph below, shows the cost of electricity at 12 p.m. on a regular afternoon at the exchange goes down to 0.3 rupees because there's so much excess. And on the same day, 8 hours later, it's hit the market ceiling of 10 rupees. That's what we're here to solve. The problem is that solar, wind, and renewables is intermittent. We're saying at a geospatial modeling level, at the building stack, and then at the systems level, we can solve for this through our intelligent powered systems, which is optimizing it real-time 24/7. I'll sort of close with just one quick statement in that solving for the energy problem is imperative for AI, but solving it right and in the green manner is imperative for our planet. Thank you very much.
Thank you for your inspiring presentation. We now open the floor for questions.
Thanks for that. How do you guys, or how would you charge for your solution by integrating the energy sources, but also creating the intelligence layer? What would you be charging, and how would you be charging it?
So we're, in the grid example, we're working with the DISCOM of Andhra Pradesh. We're not charging the DISCOM anything. We're providing this service to the industrial and commercial customers, and they pay a flat subscription-based fee to us for accessing the demand response program, because we're also seeing savings at the consumer end. So on the DISCOM side, we're providing this as a service, and we're charging the individual customers a flat subscription-based fee. And what we're now also piloting with the Andhra Pradesh project is a pay-as-you-save model. Because we've now benchmarked and seeing close to 35% savings, we're saying if we can provide a certain benchmark of savings, can we get a percentage of the savings that you make? Essentially helping create a win-win-win scenario for the grid, customer, as well as us as a company.
Thank you.
In case there are no further queries, we can wrap up the presentation now.
Thank you so much for patiently listening.
Thank you, team. We now request Forus Health Private Limited to come on the stage to deliver their presentation. The next team that will be making their presentation after Forus is Vaisa. We request them to come to the stage where we can get them mic'd up and prepared for the next presentation.
Shall we get started? Namaskar and a very good afternoon, ladies and gentlemen. My name is Shubhajit Banerjee. I lead the AI development activities here in Forus Health, which is a medtech company based out of Bangalore. Today I'm here to talk to you about a condition called retinopathy of prematurity, which is one of the leading causes of preventable blindness, and it affects newborn preterm babies, right? Every year, millions of such babies are born, and studies suggest that nearly 1 in 3 of these babies would end up contracting this condition, in some form or the other. In the very severe cases of ROP, the retina literally starts detaching from their eyes, which is what you see the onset of that in the image towards the right. So governments all over the world is taking it seriously, not just our own government, but all over the world. And they are drafting policies and guidelines to ensure that we can have and achieve universal eye screening. Yet, even globally, we are very far from having this 100% coverage. One of the prime reasons for that is an alarming shortage of specialists. In India, especially, the number of ROP specialists as low as 300 only. And the ratio is not much better globally. If you add to this the fact that traditionally ROP screening is done by hand, as you can see in this image over there, you could already see the scaling problem. So one logical thing to do is to use digital cameras so that you can delegate the responsibility of capturing images to trained clinicians, and then use telemedicine platform to review and diagnose. However, even in that case, doctors still end up spending more time reviewing than actually treating. So ROP is also not just a yes-no binary classification problem. If you are talking about in a machine learning point of view, it has multiple dimensions, and you have to characterize it properly for you to understand how to proceed further. Add to this fact that aggressive ROP needs as short as 48 hours to be treated. And the telemedicine workflow typically will take at least half a day or 1 day for the report to reach back to the parents. This is where we feel that AI can really add value, and which is where our first ROP AI solution comes in. So we are able to properly characterize the crucial aspects of ROP, such as the zone, the stage, and whether it is aggressive or not, and pre-fill it, and which will help triage the cases based on the severity. The other problem is that of image acquisition itself. So I'll try to start this video, hope it plays. This is how a typical ROP screening looks like. And if you imagine that you are the operator here, holding this very fragile infant in your hands, who is already screaming in discomfort, right? It is natural for you to feel rushed. And you may, miss out important things that you had to capture. So this is where our second ROP AI solution comes in, which is meant to serve as a real-time guidance so that operators can capture better images at the source itself, right? So the idea is that we have to ensure that critical cases don't slip through due to the lack of photo documentation. So we are designing the system to be platform agnostic. We have our own line of neonatal cameras, but we are training it with a mix of other cameras as well. And we intend to deploy it as RESTful API service, which can be hosted in the cloud, in the hospital's local LAN, or it could also be deployed on the edge. The idea is to first have our own ecosystem have these features as de facto offerings, and also we'll be open to third-party integrations as well. We intend to conclude our clinical trials by end of Q2 of this year, and then followed by regulatory submissions. Subject to approvals, we hope to start rolling out in a phased manner by the end of this year. So one of the most critical challenges of operationalizing AI, especially in the medical domain, is the last mile delivery, right? In that respect, we already have the full stack, starting from affordable hardware to the telemedicine platform, which we are already using to scale up many different ROP programs happening throughout the country, and also across the world. We don't necessarily need to depend on any third-party integrators to bring our AI to see the light of the day. We also have a global footprint. We are there across 60 countries across all the habitable 6 continents. And we have possibly the largest market share in terms of the device and the solutions when it comes to ROP care. And finally, we at Forus Health for the past 16 years have been on a mission to eradicate preventable blindness, not just in the neonatal domain, but across the entire eye care spectrum. And we hope that our ROP AI solution will help us continue with the momentum in our mission. Thank you very much.
Thank you for your presentation, team. We now open the floor for questions.
Thank you very much for your presentation. To understand your presentation better, can you explain basically you are selling the service or product?
Your voice is, I'll just come here. Hope that's better. Yes, please. Could you please repeat?
I would like to ask what you're charging on. You're selling the hardware product or you're selling the services?
We have the entire ecosystem. So as of now, we started our journey with the hardware products itself. So, so we have been selling our ROP cameras for almost 7 to 8 years now, across different parts of the globe. We also have our telemedicine platform, but we have a very modular architecture. You can buy only our device if you want. You can use only our telemedicine solutions if you want, or you can only opt to have our AI solution integrated with your rest of the ecosystem.
Thank you. I had a quick question. How have you worked with the community, the medical community, as well as parents? And I'm just wondering if there's been any concern around the technology or how you've been able to introduce it to new communities.
Yes. So absolutely, we would not be here, without the support of the medical community. And this is something which actually comes ground up. Like the pain points that we are able to address is actually coming as feedback from the community, clinical community, because they see it firsthand that babies are going blind, and there's hardly anything that can do about it. We are just glad that we are able to, provide the technological partnership for them. With regards to the babies and how to deal with the parents, usually we are working in technical collaboration with the hospitals or with the clinics. But at the same time, if you see how the procedure is, as a parent, your heart really goes out to it. But at the same time, it's a temporary discomfort. It hardly takes about a minute or so for you to do the screening, but it is for the larger good, right? So if premature babies are born with certain conditions like low birth weight and low gestation period, then you are meant to have this follow-up multiple times. Like we know cases where every week, almost for 10 weeks, babies have been followed up, right? So that is how it works.
This one, I was just trying to understand, your hardware is already out and the ROP cameras and all of that. The AI portion is work in progress right
Yes,
now.
that
And
is
so has that been tested so far anywhere, or what has been the result of any beta testing?
We are very close to starting clinical trials right now. So we are
Okay.
still refining the models with the data sets that we have collected so far. It is very close to, starting clinical trials.
So it is work in progress.
It's a
right
work
now.
in progress.
Okay, thank you.
Thank you.
Can you also share your background, please?
Can you please repeat that?
Can you share your background, please?
So 11 million people covered, 6 million people served, almost 1 billion conversations on the platform. We are the largest evidence base in the world with more than 40 research publications, multiple clinical trials we've been doing with Harvard, Columbia, and leading researchers in the world. And very highly rated on the Play stores. And we now work with 9 insurance companies across the world, multiple employers, multiple public health agencies, including the National Health Service. We cover 30% of the NHS today, and the Ministry of Health in Singapore, where Visa is being offered as a service to the entire population of Singapore. So this is truly a service or a solution built in India for the world. The underlying technology platform, it's a neurosymbolic AI architecture. So mental health, as you can imagine, is an extremely, extremely sensitive use case. So it has to have a dual, the architecture needs to manage the empathy and the conversation ability and the richness which a neural architecture gives you, but it needs to undergo and fall within a certain protocol which a symbolic architecture gives you. So we've spent a lot of time, we've spent nearly now 8-9 years perfecting this, and being deployed in institutions like Aetna, the NHS, the Ministry of Health in Singapore, have given us the resilience and the robustness and the outcomes to actually go out and saying that we really do know how to do this as best as anybody else in the world today. It is still an evolving battle, it's an evolving story, but it is also an extremely, extremely big need. So we do have a patented approach to our triage product, so where we understand what people are feeling and direct them to the right level of care. We are FDA ready, we are a breakthrough device designation with the FDA for our work in chronic pain, which is that the overlap of mental and physical health. Again, a space which is extremely hard to serve in traditional healthcare systems, but with AI you can actually expand access. So, and this is a quick snapshot of the kind of people we work with. So multiple insurance companies, travelers, Vitality, you will see leading names in the world from who are using the service, and also in philanthropy, where we comply with NHS clinical safety standards, DCP 0129, ISO, and so on and so forth. So there's a huge amount of work we've done to make this safe and robust. The product it's now much more than a chatbot. It is evolved, and it is now a multimodal hybrid service, which allows a clinician to engage the patient, send them digital homework, keep them engaged. We also have a triage product, which allows patients to get to the right level of care, which is the one which is currently deployed in the NHS, where we're covering about 40% of the adult therapy network in the United Kingdom today. Very quick snapshot of what the Visa platform looks like. It has the 3 elements, the e-triage product on the left, the patient engagement tool in the middle, and what we call the co-pilot, which allows the clinician to interact with the patient. Highest evidence of any digital mental health solution today. We work with leading institutions, research institutions of the world, and we have proven outcomes, including a 40% reduction in depression, anxiety symptoms, improvement in chronic pain, symptoms of chronic pain, pain interference, and physical function, and a host of other things, including being adjudged best in class on privacy and safety by the Mozilla Foundation, which again is one of the leading watchdogs of privacy in the world. Why India? So this is almost, the wheel has come back. So we built something in India, it has gone out into the world, it is now currently working at scale, and now we're bringing it back into India. And what we're learning is that it has actually, we have to unlearn what we have done. So I started the project, this is my last slide. So I've started we started the project by saying it's a chatbot for mental health. And then what found out was when we were trying to deploy this for adolescent girls, there are 400 million adolescents in India, about half of them are girls. A chatbot doesn't work, mental health doesn't work. So now you have to do something which is a combination of a digital and a physical intervention to allow for safety as well as access. So I'll give you an example of what it looks like. So it's a book, it's a workbook which is targeted towards the adolescent girl. It has QR codes which allows the girl, even if she is using a shared phone, taking a phone from a mother for 2 hours a day, it goes and creates an anonymous, completely discreet and private conversation on the web, which is validated and robust. But at the same time, this is being distributed through a school and through the teacher. So the parent is confident that this is actually kosher, and it is actually being given to the girl with their consent. And it is being supported by the ministry. For example, right now we are working with the government of Maharashtra, Women and Child Development Ministry. We are currently deploying something in Punjab. We won a $7 million 5-year Welcome Trust grant to roll this out in UP. And we are also working with the government of Meghalaya to develop and distribute this and take it from preventative care towards post-diagnosis support as well. So this is a topical reason, there's a very, very topical need today. AI can help solve the problem, but it needs to be integrated with real-world implementation support. It needs to be integrated with human beings. So we're learning a lot on the ground, including things like this workbook, which we're calling Dream Kit. I'll just leave a copy for you here. But that is an example of bringing AI. We started with, I think, a sample size of 1. So we were building for AI for 1, and now we've ended up building AI for all. So thank you. I'll just take questions.
Thank you for your presentation. We now open the floor for questions.
Is this voice enabled and multi-languages?
Correct. So,
okay.
Sir, our Maharashtra work is in Marathi. We are also translating this, adapting this into all Indian languages, including Hindi. Our UP work will be in Hindi. And we are also doing voice. So we have a voice prototype currently in production, and we're going to deploy it very shortly.
And how do you ensure any privacy of conversation, or is there any aspect to that? And how does, let's say, somebody in the family get alerted about a particular situation if it is going into a crisis?
Sorry, I think if I understood the question, you're saying how do you ensure privacy?
Yeah.
And safety.
And safety.
And safety. So we spend a lot of time on that. And so we comply with NHS clinical safety standards and so on and so forth. The product is anonymous. So you give yourself a nickname. I can call myself Rajnikant or Superman and have an entire conversation with Visa. So that is extremely important to build user trust. You remove that initial stigma and hesitation as well. In employer context, for instance, when the person is anonymous, they're not worried about this going into their manager, saying that they had these conversations about work or the manager and so on and so forth. So that's one. So it is anonymous in nature. And the second is, there is a lot of work now. The underlying architecture has changed from a rules-based decision tree architecture when we launched to now a prompt chain using API calls into a family of LLMs, which we are doing now. And there we are doing a lot of work in preventing both in the input level as well as at the output level. We're doing a lot of filtering. For example, PII reduction happens if you make an API call to an LLM. And there's also a risk stratification saying low-risk cases can be invoking LLM API calls, but high-risk situations revert back to the symbolic architecture. So that is another way in which we do this. We have user panels which make sure that you reduce or mitigate bias. So there's a lot of work we do in managing
At what point
security.
do you involve a human in this whole decision making or supporting, or is all AI driven?
Sorry, is the revenue? I'm sorry, there's a lot of
No,
echo.
not revenue. At what point do you involve a human in the decision making?
Humans, during the product development phase, it's a safety by design, the entire architecture. So humans, clinicians, we have about 50 clinical psychologists on staff. So
No, I'm not talking of the development. I'm talking about...
At the, So at that point, it's, there is a step architecture or a stepped care model. So the initial part is done, they say the initial assessment and the referral happens on a chatbot architecture, and there are 6 points of escalation where if the user wants more advanced support, including when we discover that they are in SOS or they're in distress, and that's a much larger, we are probably the world's leaders in thinking about safety architecture, where you push people onto a human being. But there's one point I really want to make, which is where LLMs today or AI today is failing in mental health is in SOS, is where, because of liability issues, most people are in a hurry to escalate people out into a helpline. And what we have found is about 10% of the people whom you escalate and saying, oh, I can't handle this because it's a liability issue, talk to somebody. 10% of the people who are in extreme SOS actually reach out and talk to somebody on a helpline. So the system is failing.
The quality of your service, against mental health.
I'm sorry, you'll have to, I'm very sorry, the echo is really bad.
Yeah, how you are evaluating the effectiveness of your service against mental health?
How are you evaluating the effectiveness of your solution?
How are you evaluating effectiveness? Well, we have 45 research publications across various parts of the touch point, including safety, accessibility, usability, as well as outcomes. We have done 4 clinical trials, randomized clinical trials. We have a huge host of publications which are telling us that this is working. And I think the challenge or the interesting opportunity now is to take what we have done globally and to unlearn and relearn and deploy it through mechanisms like this into, for example, we are now rolling it out in municipal schools in Maharashtra. So what we have done in the NHS in the UK or with LifePoint Health or Ascension Health in the US is not going to work in Raigad. So we have to relearn. We are doing a lot of impact evaluation work as well. Our work with the Wellcome Trust in UP, it's a 5-year clinical trial to actually first create something which is, this is pre-diagnosis. So what we are now doing is also the post-diagnosis intervention for adolescents. And there is a stepped evaluation, first a product development, which we will evaluate, and then we're doing it, pushing it through a formal clinical trial. So there's a very, very stepped process which we're doing for our impact work in India.
In case there are no further queries, we can wrap up the presentation now.
Thank you. Thank you for the opportunity.
Thank you, team. The next presentation is by Varha Global Consulting Services LLP. It is an India-based firm which is working on semantic AI.
Hi everyone, a very good afternoon. I'm Team Vajra Global, here to present SAGAR, Semantic AI Governance for Accessible Rights. The World Economic Forum's Global Risk Report 2025 states misinformation as #1 top global risk by the year 2027. And India, it's predicted to be the global risk #1 by 2027. It's not cybersecurity, it's not threat, it's misinformation. At the same time, things are changing fundamentally. People no longer access portals. They don't navigate through websites. We rely on AI systems to be able to receive our answers. When public websites were built, they were built for humans to read and not for machines to interpret. And when AI cannot understand reliably it fills the gaps with inference. And that's where misinformation begins. Not because information was wrong, but because it was not completely understandable. Let me make this real. How many of you here knew that you could update your mobile number linked to Aadhaar using the M-Aadhaar app? Okay, great. So that was a problem that I was facing recently because my dad's number was linked. I got to know that you can update, and I rushed to my trusted search buddy. I checked over to see how to update. It gave me a very structured, confident answer on how I can do it. Nothing obviously wrong, but it's not entirely right either. It still asked me to go visit the Aadhaar Seva Kendra, and that's how confusion starts. It's not fake information, but it's partially understood information. We see this across many situations. These are some headlines, places where brands were affected, places when victims and citizens suffered. The issue isn't absence of data. The issue is interpretation without context. Machines assemble meanings from fragments of data, and when that structure is not thematically arranged, it can't make an interpretation. Over the last decade, governments have done the hard work of digitization. Thousands of websites, millions of portals, and today, millions of us accessing these services online. And that effort matters. It expanded drastically and brought governance closer to citizens. But again, to reiterate that these systems were built for humans to read, remembering customer experience as the core and not for machines to interpret. Today, we search for clarity, search, help, and relief through AI systems. And when meaning gets compressed, trust becomes fragile. And the consequences are not just human. They lead from financial losses to reputation risk, to enforcement burden, and even erosion of trust. So instead of rebuilding what already exists, we want to make what already exists just machine readable. And that question led us to SAGAR. Sorry, okay. SAGAR is not a chatbot, it's not another portal, it's a foundational infrastructure layer. We studied how AI consumes web information and it retrieves fragments and infers meanings from unstructured text. Our approach is to remove the interpretation that AI does today. We analyzed the entire website and we create a connected system mapping services, eligibility, and processes together. We then build a semantic knowledge layer, creating machine-readable meaning while preserving context. This creates a parallel knowledge layer over the existing CMS. Nothing changes for the citizen, it's just how AI views the same web content that is created. We are not changing the website, we are enabling machines to make them understand better. And if we step back a little, it's not just a system upgrade, because when reliable information becomes more accessible, inclusion improves. People don't need to interpret reasons themselves or navigate multiple portals. Policy actually reaches people the way it was intended to. And that's what AI for all means. It's not just smarter interfaces, but safer access. To make this at national scale, the model matters too. We propose a public-private partnership aligned with India's TAC principles. Citizens access trusted information freely from the channel they choose. Ecosystems integrate responsibly. Revenue sustains and continuously improves the infrastructure. Inclusive and sustainable by design. The shift is already happening. AI now mediates how citizens interact with state. If we keep reacting manually, we can either keep reacting manually or we can fix foundation at once. Hundreds and millions benefit without.
But potentially, we have created simulated websites like the government websites and tested through, and we've been able to see good results with that.
Are you also in conversation with a couple of stakeholders, maybe state governments or maybe institutions, public institutions, to provide maybe testing on their data or their initiatives?
Yes, we are talking to different stakeholders. both in where we come from, Tamil Nadu government, we've been talking to a couple of the departments there. We're also working with some of the other players as well to work through this. So that's part of why we had also applied for this competition, so it will give us the access to go through with this.
And how's the response like of all these stakeholders?
I think it is definitely positive. This is looked at as a very key concern, because the whole idea of inclusivity and ensuring policies defined are reaching the citizens is a key element that every government is looking at.
And if you can talk about going forward, what will be the kind of revenue model once some sort of traction gets start building up? So what kind of revenue is, will be a kind of subscription, or how it will pan it out?
So I think Pranati touched upon it a little bit in terms of a public-private partnership. The way we are looking at it, because we are looking at it as an inclusive, citizen-inclusive kind of an initiative, we want to make sure the infrastructure layer that we build is actually made free for the government website, so citizens can easily access it through the channel of their choice. But we could also make this data available through APIs for businesses. And that would probably fund the entire process, and it can also continuously improve the overall feedback and learning over a period of time.
Thank you. Thank you.
Perfect. Any other questions? Okay. All right. Thank you so much. Really appreciate the time. Thank you.
Thank you for your presentation, team. Before we move to the next presenter, I request the jury members to kindly keep the mics closer to their mouths so that it's easier for the applicants or the presenters to hear what you're saying very clearly. And to the presenters, in case you are facing trouble hearing because of the echo, you may use the podium. Podium is a much better place to hear clearly what the jury members are saying. Having said that, now we can get to the next presentation. That's by Core Stack, a digital public infrastructure for climate change adaptation by Commons Tech Foundation for Participatory Technologies. I welcome you to the stage now.
Hi, this is working? Great. Yeah. Hi, good afternoon, everyone. Thanks so much for having us here. I'm presenting on behalf of our very unique startup. CoStack is a network startup. It's a team of many different organizations and individuals who have come together, from computer scientists, environment engineers, product managers, designers, to build this stack. So I'll begin to explain what we're doing. Through very deep immersion into rural areas, we try and really identify what are the key problems that people are facing on the ground and different stakeholders. So for example, from the standpoint of policymakers, water security is a big issue. And they face a question that structures like this farm pond on the left, which is unlined, it's helpful for drought protection and it helps improve groundwater recharge. Whereas the one on the right is a lined farm pond, which is actually used for pumping groundwater and for storing it. Which of these structures is more suitable in a particular landscape? How many such structures can a landscape support? That's important from a policymaker standpoint. For communities, similarly, many communities want to revive traditional water sources and systems where, for example, nutrient-rich runoff that makes its way from hills, forested hills, that's very useful. How do we revive these systems? Where do we get the funding? How do we make that whole process smoother? And all of this in today's context, where rural communities have very strong aspirations for social mobility, economic mobility, but how do we make sure that it's all together within the ecology boundaries of that particular landscape? The way we are doing it is in a digital public infrastructure manner, where we have brought many different geospatial data sets together. Many of these are models that we've built ourselves on how land use is changing over time, canopy density, tree health, water stress, how is it all changing over time. On top of these, we build different kinds of models for extracting intelligence, almost like a root cause analysis, that what kind of a problem is a particular landscape facing and what solutions are most appropriate. All of the data and layers are openly accessible through APIs. The data sets are openly shared. And on top of this, we are also building applications for different kinds of stakeholders. So I'll demo some of these. Know Your Landscape is to understand how in a particular landscape, what are the diverse sets of problems that are being faced so that program managers or district officials can design interventions appropriately. Commerce Connect is an app in the hands of the community. Somebody in the field, a community volunteer or an NGO frontline worker who can actually build a micro plan that where exactly in this village should we have a farm pond, where exactly do we need check dams. And similarly, this is really an open ecosystem. We're already seeing many people who have started to build on top of this. So we'll quickly look at this demo of the Know Your Landscape. Let's see if it works, yeah. So for any state district tehsil, we get that description. Here, for example, you're seeing a terrain layer which sees which areas are plain areas, which areas are slope. We've got rainfall data sets. We can identify which of these areas are drought prone areas, which of these areas have a higher sensitivity of surface water stress. So now in these particular areas, some particular, a very targeted intervention can be designed. These kinds of reports come out automatically, which present statistics on different land use, how things have changed over time. So for example, which areas have seen degradation, that crop areas have degraded to shrubs, or how is cropping intensity, tree cover changing over time, surface water stress, rainfall, evapotranspiration, groundwater stress. All of this information is available in one place. And the next level of intelligence that we're adding on top of this is really customizing all of this to understand what's happening. Similarly, we've built a unique way of describing landscape entities. So we automatically identify surface water bodies. Here we can see how is the water availability changing over time. What is the cropping pattern around this water body? How has that changed over time? Where is this water body located in a particular landscape? And all of this is very helpful from a policymaker standpoint. Yeah? And we'll go to the next, right, which is now an app. This is now bottom-up, right? What I showed earlier was top-down. This is an app which is now in the hands of a frontline worker, that they can actually go to that location. It's also available entirely offline, and they can build plans in consultation with the community. The key part over here is participation. And so the way it works is that they sit together with the community, they see what kind of works have happened in the area, so that the community can also discuss what kind of works are happening in our village, what works are happening in other villages. These are other layers that show what kind of groundwater recharge is happening, which areas are good for groundwater recharge, and so on. Yeah? So as a result, after all of this process is complete, these kind of forms are filled in consultation with the community, that what kind of demands does the community have for different kinds of water structures. And these forms can be filled with dimensions and such details, and that can be put forth for taken to the Gram Sabha and Panchayat and so on. I'll quickly wrap up. The key part of all of this is that it's already, over the last 1 year that we've been in the field, is being used by in 800 villages. It's led to a lot of reduction in time, and it's helping improve the quality of planning happening in the area. People have already started to build on top of this. We're running an innovation challenge where people are building new kinds of solutions using all the data sets. To make all of this financially sustainable, actually we need to work with the community, and our whole idea is that how do we empower the community steward so that they can more effectively build such plans, be in the village, one person per panchayat, and build these plans with the community. And for that, we are building a dashboard where all of this is entirely visible, who's working in which area, what kind of plans they're building. We attach projections that as a result of this plan, how much groundwater will be saved, how much carbon will be sequestered, and so on. And our goal is that in the next 5 years, can we enable 25,000 such landscape stewards to come forth and have a platform where people can come, they can commit funds to funding these landscape stewards. Yeah. So I'll stop here. Like I said, we work with a very large network of partners, and this is all done together with everyone. Thanks.
Thank you. You touch upon it in the last slide, but can you tell us a little bit more about the team itself and their areas of expertise and how you think about scaling with partners?
So was the question, what are the expertise of the different partners? Yes. So I myself, I'm a faculty at IIT Delhi. I teach in the computer science department. So I bring some of the computer science kind of background in terms of analysis of remote sensing data, satellite data, machine learning, AI, all of that. We work with then environment organizations like Well Labs and Atri, who have a very deep expertise on hydrology, on ecology, all of these aspects, as well as a large of our partners are actually organizations, implementation partners working on the ground. So they are the ones who are actually bringing the problem statements and establishing the community interface.
So from your point of view, who are the real beneficiaries of the system that you are developing? Is it government authorities or is it specific communities? I mean, I was not able to figure that out.
Yeah, so in theory, the platform is a digital infrastructure, so anyone can build on top of it. But the key constituent for whom we are building is a landscape steward. So this is a person from in the community, a community volunteer or an NGO worker who can use these tools in consultation and participation with the community to improve the overall resilience of water security, forest restoration. So we're adding more and more domains and modules into our overall stack. And
are there a couple of examples that come to your mind in terms of real positive impact or major impact so far?
Examples of how they've
impact.
used it?
Yeah.
Yes, absolutely. So many of these plans have already been submitted to the Gram Sabha and they have also been approved further on. So these are largely about, a lot of it is around what's called watershed development, ridge to valley approaches, that where can we have gully plugs to improve groundwater recharge and what is the downstream catchment that they would influence. So many of these farm ponds and check dams have already been sanctioned by the government. So that's one kind of a trajectory. Similar up and get it going. We're gradually moving there.
In case there are no further queries, we can wrap up this presentation.
Thank you. Thank you. Thank you, everyone.
Thank you, team. The next presentation is by CarbGem Inc. We welcome you to the stage now, sir.
Okay, good afternoon. Namaste. My name is Masa Nakajima, CEO of CarbGem. I'm coming from Tokyo, Japan. Now, India is facing one of the world's serious threats around antimicrobial resistance crises. But root cause is not lack of antibiotics. It is the lack of rapid microbiological interpretation at the primary care settings. That is the problem we are solving. Across India, especially in Tier 2 and Tier 3 cities, there is a severe shortage of trained microbiologists and technicians, professionals. Ground stain interpretation is often unavailable at night, on weekends, or in remote areas. So physicians or doctors need to prescribe broad-spectrum antibiotics empirically, which means just in case. This accelerates antimicrobial resistance, which is AMR. This is not a technology gap. It is a human resource gap. And AI can extend skill expertise. So BITE is an AI-assisted ground stain interpretation system. It works with existing microscope and any smartphones. A technician or microbiologist take a picture of the images from microscopy and upload it securely, and wait 10 seconds, they can receive AI interpretations, which means that no new hardware is required and no workflow disruption will be expected. BitA supports laboratories. It does not replace it. We have a demo movie, but because of the time constraint, I want to skip this time. Okay. So trust is very much critical in healthcare AI. BitA Urine is approved in Japan as a Class 2 software as a medical device by the PMDA. It was co-developed with leading university hospitals in Japan, and in a peer-reviewed study published in the Journal of Medical Microbiology, BitA demonstrated non-inferior performance test compared to the microbiology specialists. This regulatory and clinical foundation makes BitA deployment ready. Technically, BitA is built for real-world lab conditions. It uses multi-level deep learning to handle polymicrobial samples, variable staining quality, and constrained network environments. It is resource optimized and cloud-based. Importantly, this system is human in the loop. The clinicians and doctors always remain in control. BitA creates measurable impact, the faster preliminary assessment, and better antibiotic targeting, and reduced unnecessary antibiotic use. And our business model is very much simple. This is B2B subscription, which means no upfront capital investment is required and no equipment replacement is required. This makes it highly suitable for district hospital and diagnostic laboratories. Affordable and scalable and sustainable. This is our core philosophy and value propositions. And our expansion strategy is structured. First, PMD approval in Japan. This is already completed. And second, local validation with Indian partners. We are trying to find a good partner in India to roll out this project. That is why I came here this time. So I am very happy, very open to find any proposal to work together. And third, integration into digital health ecosystems. And finally, targeted deployment in Tier 2 and Tier 3 cities. We are supported by MEDI, EMEDO, and JETRO, and MEJ for global expansion. So we are trying to by using BitA, democratize microbiological expertise. So our AI should not replace specialists, but it should extend their capabilities and push beyond their limits. That is our vision. Thank you very much for listening today.
Thank you very much for your presentation. Can you explain a little bit more about deployment record in Japan or some other countries?
Okay, yes, a very good question. We got approval from the Japan PMDA around a year ago, and we already deployed more than 25 hospitals in Japan, and we are working with top-tier hospital in Indonesia and Vietnam to test and validate our AI. So next target should be in India.
So has this been implemented in Japan, and what is the impact of using this, and what is the current plan for India in terms of, has it been tested out here? I know you're looking for partners.
Yes, actually, we're trying to find a good partner how to roll out, how to localize these products. One of the targets will be some manufacturers or AI developer or government stakeholders. So, but still, we are now under the investigation.
Thank you for your presentation, team. Now, before we go ahead with the next set of presentations, I'd like to inform the participants, the jury members, and the wonderful audience that we have reached the half mark. Now, we are through with 10 presentations. We have 10 remaining. We'll be taking a short 5-minute break, and then we will be proceeding with the next set of presentations. Thank you for your patience.